Hey guys, want to show you another way of factoring. If the first three that we already know don't work, and I've showed you this briefly, I'm going to show it again just for the video. We always look for a GCF first. This one doesn't have anything. Nothing's common to all three of these. So we look next for a difference between two perfect squares. This isn't even a binomial, so there's no way we can have a difference between two perfect squares. Then we look for a perfect square trinomial. This is a trinomial, so it could be that, but it's not because 21 is not a perfect square. So we have to eliminate it automatically. Now we're going to go to the fourth method. When we have something like this, but 1, 2, and 3 don't work. So here's what we do. We are going to turn this into two parentheses. So it's going to be one of these and one of these. Just like when you FOIL two parentheses like that, you're going to end up with a trinomial. So we're doing that backwards. So what we need to do is we need to find two numbers that add up to negative 10, to positive 10, and that multiply to positive 21. So all we have to find are two numbers that add up to positive 10 and multiply to positive 21. While we think about those numbers, if you have an x squared here in the front, which you always have if you're doing this method, just put the x there and the x there. If you have an x there and an x squared, it's going to equal an x squared up at the front. Now, what two numbers add to positive 10 and multiply to positive 21? How about positive 7 and positive 3? That works, right? So what we do is just move this positive 7 up right into here. And this positive 3, we just move it right up into here. So this x squared plus 10x plus 21 factored is x plus 7, x plus 3. Then we ask ourselves, are we done? Well, let's look back. Is there anything we can GCF out? No. Are there any difference in two perfect squares? No. Is there a perfect square trinomial? No way. So we've done our work, and what we're going to call this method is the Katz certified factoring method. This is the main way you factor these things after these special cases kind of get worked out. This is kind of like the nuts and bolts of factoring. And we're going to call it the Katz certified method. She's the one that taught it to me. Hope this helps. Hey guys, I want to show you one more factoring problem. Let's look at this one. X squared minus 2x minus 63. We always go through our list. We always look for a GCF first. I don't see anything there. We always look for a difference of two perfect squareds next. This is not a binomial. Cannot be a difference between two perfect squares. Then we look for a perfect square trinomial. 63 is not a perfect square, and anyway, you can't have a negative there if you have a perfect square trinomial. That one has to be a plus. So we know it's none of those things. So we got to go to the Katz certified method, especially if we don't have a coefficient or any number in front of the x squared. If we have a number in front of the x squared, it's going to be a little harder, and I'll show you that next time. For right now, I want to show you the Katz certified method for factoring. So what we need to do, we need to find two numbers that add to negative 2 and that multiply to negative 63. The way we start is basically by listing factors of negative 63. So I could go negative 1, 63, 1, negative 63. What else could I do? I could do 9, negative 7, or I could do negative 9 and 7. That's all we might need for now. Let's try those. Oh look, well negative 9 and 7 are negative 63, and negative 9 plus 7 is negative 2. So these are our two numbers. Looks like negative 9, or let's call this one positive 7, and this one negative 9. So we have negative 9 and 7. I just switched the order. It shouldn't matter. Then when we actually factor it, we know there's going to be an x here and an x here. because that's an x squared, and x times x, or x squared, the f in FOIL. Then all we do is move these guys up. So x squared minus 2x minus 63, fully factored, is x plus 7, x minus 9. Now to make sure it's fully factored, we got to go back through our list. Is there a GCF in either this parentheses or this parentheses? No. Is there a difference of two perfect squares in either of these two parentheses? No. Are either of these two parentheses a perfect square trinomial? No. We just Katz certified methoded it, and I don't see anything else we can do there. So we're done. This is the factored answer. X plus 7, x minus 9, both quantities. If you FOIL them out, you're going to get exactly what you started with, which is the check, and we'll let you know that you did it correctly. Hope that helped.